Good morning and welcome to day 3 of our virtual IoT event. I certainly hope that you've been taking away some valuable insights during this week. And I also hope that you've been doing some virtual networking. We'll kick off this morning's presentations with insights into how to evaluate several of the leading machine data solutions for small to mid-sized manufacturers so that you'll be well equipped when you start looking at how to bring IoT to your own plant floor. Our speaker this morning is Sharon DeVos. Sharon is the founder and CEO of IoT Automating Solutions. In that role, Sharon helps manufacturers understand how the industrial Internet of Things, smart manufacturing, and big data technologies have the power to drastically improve efficiencies, customer experiences, and employee engagement. So please welcome Sharon.
Thank you, Brad. I'm so glad we have a chance to talk to our small to mid-sized manufacturers and even some very big ones. It's so difficult these days when we can't actually see each other face to face and really get together and brainstorm what's the best way to connect our equipment to see things virtually. You know, on this topic, one of the things that comes to mind right now is I recently heard of a company that had just implemented such a system. And they said that they had no idea when COVID hit and all of this hit, how vital it was going to be for them to actually be able to see what was happening on their shop floor. It really made it possible for some of their employees to be able to work from home and other employees who were vital to be in the shop and everyone to communicate together. So this is really a very timely topic to look at how we can evaluate IoT solutions for manufacturers. And today I hope to give some really practical advice to those of you out there who want to get something going. You need to select a solution, you need to get going, but you're not really sure where to start with that selection process. So as we get going, first thing I want to talk about is just all of the language that surrounds this particular topic. We've had a hard time as an industry even knowing how to describe it. You've heard the words Industry 4.0, IoT, IIoT, machine monitoring, manufacturing analytics. I just threw a whole bunch of these things on the board just so you could see that there really is so many different ways that we're talking about it. And the companies that use this terminology are all going to have their own take on what that looks like for them. A manufacturing execution system or a manufacturing operations management system has some component of connecting to machines and collecting machine data automatically, but they can be much broader systems as far as the analytics of using that data. And then the system that most people have heard of for a number of years now is just called machine monitoring. And machine monitoring collects your uptime and your downtime. Usually we'll collect downtime reasons and help you begin to see when you're running and when you're not. And then also the word OEE is becoming more and more popular. Some of you have heard of it and other ones have not, and I understand that. But OEE is a very simple way to measure your overall equipment effectiveness and the inputs it requires as far as data. It's really effective to measure this with real-time machine data, because real-time machine data can tell you how long it's taking to run each part. You know, what is your cycle time? It can tell you, you can input into it how much time is available in a given, over a given shift, for example, or over a 24-hour period to run. And then it can tell you how much it was actually running and how much it was down. And it can even tell you how many parts are good and how many parts are bad when it's integrated properly. So OEE software is another terminology that you're going to see when you're out there and you're looking up solutions and trying to decide what you're going to do. Of course, the word IoT, Internet of Things, is the bigger concept, basically making this available on a platform that you can visualize from anywhere. So without further ado, I'm going to go over with you what today's discussion is going to cover. We're going to be looking at the 8 topics that you really need to evaluate, understand, and document for your organization to create your list of requirements for your platform. I'm also going to talk about the 3 primary approaches that are used for data collection. And I'm going to give you 9 actual companies and solutions to consider. You're going to hear from some of them directly in this conference, and please, they know exactly what they do much better than I do. But I thought it might be helpful to some of you to actually see some of these side by side, to see what some of the options are that have been both presented in this conference and some that have not been presented here, but you might want to think about. I'm approaching this from the perspective as an outside consultant, and I really don't have any particular allegiance to one solution over another. What I want to do is give you the tools to pick what's best for you so that you can get going on your digital transformation strategy. There are also 5 steps that I have put together for just selecting that IoT machine data solution provider, or whatever name that you happen to use across this list of terminology. But just some things that I'd recommend that you do to step-by-step narrow down and select a good partner for you. So let's get going with listing your requirements. When you're starting your digital transformation strategy, you do want to start with a statement of purpose. I'm going to go into a little more depth in that here later on, but you are going to want to begin with the end in mind. What are you trying to accomplish and why? You'll need to think about, what machines do I want to automate my data collection from? Which ones now, which ones in the future? I'm going to give you actually what data, what you need to record down, so you'll be prepared for this. And then we're going to look at other processes that you might want to monitor in parallel with automated machine data. And you're going to need to think about your data requirements. How are you going to collect the data? What data do you really need? Both today, tomorrow, a year from now, 5 years from now? These are things that you're going to need to think through as you list your requirements, so that you pick a solution that's capable of not only meeting your immediate needs, but meeting your long-term needs as well. And of course, what good is data if you can't visualize it and use that data to really drill down and understand what it is that you need to do to improve your business operations? What people need to see what platforms do they need to look at? This will be a part of your requirements as well. And then there's the HMI, or human machine interface. Physically, what are people going to be touching, and how is that going to change from what you had today into what you want tomorrow? You'll want to think about, how much flexibility do you need for creating dashboards, views, and drilling down to actually find problems. And security requirements, both your internal, that means your user securities, and your external, how to keep your data safe from the outside world. So are you ready? Let's deep dive into each of these 8 areas a little bit. So the statement of purpose. Only you know your company and your company culture. So I've just made up sort of a broad statement, but you need to make this your company statement. Why are you doing this? Well, I wrote down that a metal forming company currently enters their machine running start and stop times, as well as production data at a workstation on the shop floor. It's actually fairly common if you have a well-implemented ERP system that you're already collecting the basic information that you need. The only difference is you're not getting it in real time. You're getting what the operator has interpreted as start or as stop, and there's always some fuzz when a human enters data. So one of the reasons why some companies want to implement this kind of automation is they could be doing it so that they could get more accurate information. It won't be subject to operator interpretation, for example. They also want to reduce their downtime, improve visibility, improve on-time delivery, increase overall equipment efficiency. Maybe really know what it is in a way that nobody can argue with it. Maybe get one version of the truth. Maybe you want to, you suspect that you need to invest in some other equipment, which is going to be more efficient, but you need the data to back that up. There's a lot of different reasons why people go down this journey, but it's something that you need to talk about. What is it that you're trying to accomplish? So now that you know the what and the why of your IoT journey, something you probably talked about before you started listening in today, you're going to need to collect your machine or your asset list. It may or may not be machines. But think through, what is it that you want to connect? And then you're going to need to just create a spreadsheet. Basic old Excel here works just fine. You probably already have this, but it's important that you list all of the machines and assets that you're going to want to collect. You're going to want to include your planned purchases as well, so that you're forward thinking before you select your final IoT platform solution. So at a very minimum, you need to have a machine ID or identifier, the type of machine, like here I wrote a punch press, the make, the model, serial number, and the controller type, and then the model year for that equipment. This is the first thing that any company you go out for a quote is going to ask for. They're going to say, well, what do you want to connect? And I need this basic information. Some people give you templates to fill in, but hey, you can do this on your own. You don't need a template from one particular IoT platform to make your list. So why the model year? Well, legacy equipment may need hardware boards, and you're going to approach connecting that equipment a lot differently than you're going to approach connecting the newer machines. So you might need, the new machines are going to be capable of direct connection more than likely, but this is going to be important to just make a note of. And you're also going to want to think about your non-machine processes that are going to be monitored together. Sometimes it's better to see everything all at one time. You may have manual assembly work that doesn't have any way of collecting data, but you want to see how many pieces they're making, how long it's taking, who's working on it. You might want to see the information, and you might want to see that information in the same database, in the same system that you're collecting your automated information from. So think about, what else are you going to want to see along with your basic machine information? Think about other manual processes. Often these are considered work centers or work groups, or they're a center within your ERP system, and that you're going to want to see in parallel to. So I know you don't want to have a lot of manual processes, and maybe one day you're going to add more sensors and vision systems. You might add belts. Who knows what you might do in the future to make these things automated in the future, but it's good to have a plan for what you're going to want to see. All right, so let's dive into data requirements. How to automate basic data collection from a machine. I'm going to give you the really high view, then I'm going to go a little bit lower, but you're going to have to get the details, the technical details, actually from the providers that you're getting quotes from. So the very high view is you're going to get your basic data from your machines either as a direct connection. I like to call these native. These are native to the controllers that you already have. And the kind of the big ones in the room are going to be called OPC, Empty Connect, and Bonnet controls. But there really are a plethora of other types of controllers that are really OEM specific. If you have machines that are capable of providing direct information, then that may be a way that you want to use it. And then you're going to have hardware. Some of your equipment, and most companies that we see today have a mixture of older equipment and newer equipment, either because you've matured as a company or perhaps you prefer to buy used equipment. It doesn't matter. You can connect anything, and you can see it all in one place if you have the right kind of platform. So hardware needed. These are I/O devices or input-output devices that get information from your older equipment and then pass it along so that it can go into a database where it can be retrieved in real time and used. So there are a number of ways that you can do this. There are branded boards from a number of IoT vendors. They make their own boards or they provide their own boards, and this will be a part of your quote. Some companies go out and do this on their own. A Raspberry Pi, it's not something just yummy that you eat. It's actually a really tiny computer that's used to collect information. And bigger companies are buying their hardware separate, their software separate, and they're putting all these things together. But I really recommend for most of you, you're going to want to find a solution provider that can do the whole package for you. It's someone who does the software aspect, and they also provide the hardware, and they support it all together. So that's going to be my recommendation for small to mid-sized manufacturers. In fact, that reminds me, Many, many years ago when ERP was first getting started, a lot of companies tried to build their own ERP systems. They said, nobody understands what we do. We'll build the whole thing ourselves. And that's how things were done from spreadsheets and from in homegrown systems for so many years. And then at some point in the last 15 years, 15 or 20 years, most companies have come to realize it really makes sense not to have your own programmer. You really need a company that specializes in it. And I'm going to say the same thing goes for selecting your IoT provider. Think about it, get someone who's a specialist. And those are the companies we're going to be looking at today. Specialist companies who know how to both collect the data and help you visualize that. All right, I got off on a tangent, just like I was up in front of you talking right now. Anyhow, data requirements, what data to collect. I'm going to show you some of the different data types that you will want to collect, perhaps, as you're writing down those requirements for you. So first you have machine data, and machine data could be the state. The state is currently in the state of idle. It is currently in cycle. It is at e-stop. These are different states of a machine. You also have custom data, things that are custom perhaps to your job, things like the program number, an override on the machine, a tool ID. And then you have process data. These are elements from sensors for machine health, things like temperature and vibration, the current electrical draw, pressure and load. These are different types of machine data that you should be able to collect. And then you need to see this machine data together with your job data to really make it useful so that you can drill down and understand things. Your job data typically comes from your ERP system, whatever that is. It's used to identify operational activity. It's the basis of your performance indicators. It could be your operation step, your product standard. You've got job numbers and part numbers and descriptions and sales orders. And yes, there's lots of different things within your ERP system that you're going to want to slice and dice your information by. And if you're going to see that, be able to filter and drill and make beautiful dashboards and see things, well, you have to collect that data, and it needs to be related to your machine data. And then there are operator states. These are non-operational states where the machine can't tell what's going on. These are things that your operators actually have to input. They have to actually identify the reason something is down. Well, it's amazing how important your downtime reasons are, and yet so many companies don't know why they're actually down at a given time. They just assume, well, we don't have any more work for the machine, or they may assume that the material hasn't come in yet. But a non-operational state is something that can be easily put in by an operator who actually knows what's going on your shop floor. These downtime reasons might be things like no material. You could have a full chip bin. There could be breaks or meetings, things that are actually scheduled. And then there are override conditions where it would appear from perhaps the electrical inputs that the machine is running, but really it's in setup, or really it's in maintenance, or it's dry running something. There's a lot of different states that the operator may need to input to override. And these are things that you'll need to think through as well. And then of course, you need to know your shift data. So many companies want to know what shifts are more effective. One company in particular looked at their shifts, and there was one shift that was outperforming everyone else. And they drilled down into this one shift and asked the questions, why was this one shift outperforming? And the answer is that they found, because they had machine data, surprised them, and they actually were able to drill down and find out what was going on. Now, let's think about our visualization needs. So visualization literally means seeing. What can we see from this data? Well, we need to think about the physical platform that we want to view our data on, right? Everyone has cell phones these days. And I know it's always a difficult thing on the shop floor. Do I let them look at their cell phone, or should that be tucked away? Can't the cell phone be a distraction? Or perhaps you decide the personal device is what you want everyone to use to do their jobs better. There's tablets, There's a number of different, of course, computers. You got things already on the system. We have large displays. So a large display in a work area that's publicly available to the employees working in that area, you would be shocked at how much of an increased improvement you get just by putting it up, just by simply having red and green. It's running, it's not running. There's a little bit of social pressure, you might say, when there's a big red up there on the screen and your machine isn't running and there are all these jobs waiting. So you'll want to think about what large displays and where you want to put them and what information would you want to see on those displays. This is where your departmental conversations become very, very fruitful as you talk about it ahead of time. What are we going to do? And then, of course, you have existing computers on your screen. I mentioned handheld devices, phones, and tablets. You'll want to think about, is it going to be app-based or web URL-based? And then you're going to think about the people, the job functions. Different people need to see different information. They are responsible for different things, and you'll want to think about how customizable is the solution that I'm looking at. Is it going to allow me to put up give certain information to operators, perhaps, and managers are going to see something that's bigger, and then they need to be able to drill down. You have your CEO and management. They're interested in a much bigger view than, say, quality. Quality department is going to have different visualization needs, as your operators are for each of their departments, and production management. And so these are things you'll want to think through. And then you have the human-machine interface. All right, besides just viewing the information, like I said, viewing it on a device, some people will need to interact with that information and actually input data. So what platform will the operator use to enter data and see information? It could be a new program that you see when you go through your demos that looks fantastic, and you're going to say, this is way more intuitive than my ERP system is right now. I'm ready to switch because I really like the interface. You'll find that some of these IoT platforms were developed by manufacturers, and they were really thinking in terms of what is it that people on the shop floor are going to be comfortable inputting, and what information do they need to see. And these come pre-built. These are software packages that are fairly pre-built to meet the needs of an operator. And you may want to replace your ERP system and then only have in the back end information going into your ERP or to and from your ERP. We'll get into integrations here a little bit more in a few minutes. So we have job data that's pushed from the ERP into the new program. That's what job is it, right? What's the customer, what's the part number, the description, that kind of thing. And the operator just pushes a button to select it, for example. You also have a new program that is separate from the ERP. You could have operators that may have to, for a while, scan a work order in their ERP and then in the IoT platform. I know it's not ideal to have to do things in two places, but understand that as you go through this journey, and IoT is a journey, there are going to be phases to your implementation, and it may require some duplicate scanning for a while. So you also could have it in the current ERP. Some companies say, well, my operators are so comfortable in our current ERP system, and they've got a good shop floor graphical interface for my shop floor employees, that I just want the new data, like that needs to interact with this machine. I just want that to be visible within the ERP. And within that, you're going to have some options. You're going to have new fields that you could add into your ERP, which the operator inputs, and those are linked into the back end of the software platform where your live data is being aggregated and then made so that you could present it in report format. Some people within their ERP system, some ERPs actually allow you to have a window that pops up, and you're actually in the window, you're actually inside of your new software platform. You could have a frame, like I said, a link clicks you out. A frame is inside of it, I'm sorry. So you're going to think about, what are my integration needs in the long term? A lot of companies don't do any integration to start with, but it's really important that you think through what that integration is going to look like in the long term. So integration, when it's non-existent, that means your job data will have to be entered manually or scanned, or Perhaps you don't even collect it. You just care whether the machine is on or off. You could have, as part of your integration, you could have information from your ERP, your job data, that just goes to your IoT platform only. And then once it's there, you can manipulate and see information using that software tool. That's one direction, from ERP to your machine data solution. And then bidirectional, and this is really where the power will come in. But again, this is probably going to be like a phase 3 for most of you. So bidirectional, your ERP sends job data to your machine data solution, and that machine data solution sends back the work detail records. These are the times and the counts into the ERP system. So rather than having the operator click a button that says, I started this machine, I stopped running this machine on this job, then that system is going to send over those work detail records. And it'll also send over the counts, how many parts were made, if that's the way that you want it set up. That's a bidirectional, kind of a more advanced phase of your IoT plan. And it's something you want to talk about. Even if you think, well, I'm not going to do that for at least 3 years or 5 years. Make sure that the company that you're working from has either done this before, has done it with your ERP system, or has plans to do it. You're going to need to get kind of a warm and fuzzy feeling in your conversations that this is going to be something that's possible. So moving on, another part of listing your requirements, you're going to want to think about what kind of flexibility do I need for creating dashboards, reports, notifications. Some companies have like a company admin that's going to create and maintain those dashboards. You're going to create what it is you want to see, and then you're always going to kind of look at the same thing. And that's kind of the simplest dashboard. Other people want those to be able to be created and changed and monitored and edited by your managers and supervisors. And that's something else to think about is the drill down capability. How do I go in and find out when I have a question? Let's say a particular shift had really lousy OEE. Well, why do they have lousy OEE? Which machines were causing the problem? Which operators were causing the problem? This is the kind of information you can get from these systems. So you'll want to see a good demonstration of how an employee can drill down and find out what went wrong. And then you want notifications. Look at your notification options. Does the solution give you a way to send out emails, or do you want emails? Or maybe you've gotten rid of them altogether. Hey, we're in a new age. It's text messages and pop-ups, right? Right before this presentation, I was trying to mute my pop-ups, and I said, is there a way just to turn off all these dang pop-ups and notifications? I have them coming from everywhere. But of course, that's because notifications really work. Think about what notifications you want your employees to see. How can you silence the notifications they don't need to see and make really visible the notifications that they do need to see? Those are things that you'll want to think about, where it needs to pop up. Perhaps it's on the ERP computer that they're on now. Perhaps it's on their cell phone. And your company culture is going to dictate some of that. And of course, there's text messages, right? Okay, so I'm only going to hit on security briefly because I'm not a security pro, honestly. But you'll want to talk about it. You'll want to think about user security. You've got different users in the system. Everyone should be able to visualize or to be able to see this information, but who can enter what? You also, of course, have your data security. And this kind of draws us into that big question of where am I going to keep my data? And this is a very confusing topic because you can be sold either direction. And I really don't care. I think on-premise is great. I think cloud is great. And then edge also, that just simply means that some calculations are happening right at your machine and it never goes out. That data doesn't go out any further than the calculated data. And it has some safety in it as well. But those are kind of three categories, I would say, of data security that you'll want to understand. And this is going to be a conversation between your IT resource and that IoT platform provider that you have. So some of the companies now are offering cloud solutions. And when we say cloud, all it means is basically they have contracted with a big organization like Google. They've essentially bought servers somewhere in Seattle, right? And they're saving all your data there. That's really what cloud is. And you're accessing it over through many encryptions over the internet. Whereas an on-premise solution is literally a server that sits right there under your roof. And it has to fall under the security policies that are set up by your IT company. Some people have to go with on-premise because they have certain security policies that right now can met by like an aerospace company. Maybe it's medical devices, depends on what industry you're in. Some of them are going to require on-premise, but cloud certainly has a lot of advantages. And that's kind of rented data space out there. I would say pretty much every IoT platform company you talk to is going to say they can do both. Pretty much. Most of them will say, I'll do both. But I'm going to present, as I actually talk about real solution providers, I'm going to tell you what they're kind of best at, what their niche is, from what I have had in conversations with them, what I've found on their websites, that kind of thing. So, because some certainly specialize more in one than another. But one of the biggest differences between cloud and on-premise is just cost. So when you're renting space in the cloud off the internet, right? When you're renting that space, you're going to have a much lower upfront cost, and you're going to be on a subscription service basically. And usually that subscription service is going to be by machine. So however many machines you have, multiply that times the cost per month. It could be $100 a month, $250 a month per machine. Could be a wide range, quite frankly. And that would be your cloud. So it's easier to kind of get into IoT on cloud. Now, on premise, a lot of times those are sold as software licenses, and all of that information sits on your server under a software license. And then you have a much smaller ongoing maintenance cost with an on-premise kind of solution. So let's look at the different vendors involved. Now, I've been talking about an IoT platform. This is the core program, the core company that's going to do your database management, and they're going to collect the information and put it into that database, and then they make it available so that other companies, usually via an API call, are going to be able to get to that information as well. There are third-party integrators as well that you may want to bring into the conversation. Someone who can bridge the gap between, for example, your ERP system and your IoT platform. Of course, the ERP company itself might actually do the programming for you. One of the companies that I work for is called Global Shop Solutions. They're a major privately held ERP company, and they have a whole team of programmers that does this kind of thing. And so they'll actually create the integration with any other IoT platform using their own methodology to connect in and make the connection. Other vendors that you may be talking to in this process are going to actually be your machine OEMs, and you're going to be getting controller information, and you may be thinking about, this is if you're going to go that method of direct connection like I mentioned earlier. And then there's the hardware, or the I/O boards. These suppliers, usually you'll purchase those boards from the IoT company that you're working with. They're going to have their own proprietary boards, but not necessarily. You may actually be able to just buy that separately as well. Something just to think about. And then down the road, you may put additional sensors into your equipment. And so you may end up with another hardware supplier. And you want, of course, all of these different vendors to talk nice with each other, right? And don't forget to involve your IT company. You need a good, solid IT company to at least be involved in this process. So from an infrastructure side, you have what it takes to connect. I mean, you got to have a really great wireless system. You might want it wired around your shop just to make things run smoother. But your IT company is going to make sure that you have the structure there for the store. So I could have led off with this non-technical key info. Sometimes when I'm selecting a vendor, These are the things that I go to before I even get to the technical aspects of things. I like to know when I'm picking out a company, especially something like an IoT platform. Who owns the company? Is it privately held, publicly held? How old is it? How much experience do they have? You get some of the historic background in this. I would say, unfortunately, what I've seen in the past few years in this space is that companies have come and gone. You really need to have a good feeling that a company is here to stay. And these questions that you ask them are going to help you know for sure, give you a better idea of the long-term viability of your relationship with this company. Of course, industry experience is important. Have they connected things in your industry? But they don't really have to. Keep that in mind, that even if they've never connected a particular piece of equipment or have experience in your industry, you may not be able to find that or have many options. So I wouldn't make any one of these bullet points the only criteria, but you certainly need to know for all of them. I would talk about their R&D investment strategy. What are they doing as far as new features? What is their growth plan? What is on the horizon for this company? If the company is not doing any research and development, if they're not investing in their own product, working out bugs and improving their product, I probably wouldn't select them myself, honestly. And then you're going to want to look at customer support. What hours are they available? And get a feeling for what that support is going to look like. And I would definitely suggest doing a site visit. Go see some customers, that they at least do one site visit for the top 2 IoT platform providers that you're considering. Talk to them or find out the number of employees for the past year and their current number of employees. I mean, are they growing or are they shrinking? You want to kind of get a feeling for this. Last 3 years growth, how have they been doing year over year? Of course, with this whole COVID, this huge mess we've had, and it's, you know, things kind of stopped the last few months. So I'm sure you'll take all that into consideration, the economic situation. But these are still great indicators and definitely part of that first conversation you're going to have with a salesperson before you send them over your machine info. You're going to want to go here. And most people will tell you right on the phone their cost per machine, their initial ongoing cost. You can at least get an estimate. Some of these companies have got it posted right on their website. It's really easy to actually go in and get an estimate. What is it going to cost? So, of course, cost is key to this whole thing. Okay, I'm going to transition a little bit here and talk to you about the 3 primary approaches to collecting machine data, at least the way that I see it. And I'm really not a technical geek at all, but I found this helpful when I was developing a framework. You have native connections. You have an input device or hardware that is on your machine. And then there are electrical signals, ways to use electricity essentially to get you your basic information. Now, none of these are better than any other. And some companies focus really heavily in native connections, and they have huge lists of all the types of machines that they've connected to natively. And once they have that kind of library built up of things they've connected to, it gets easier, honestly, it gets easier to connect. And then they have all of the data gets funneled in into a database, that live database with the native connections. And that just simply means you didn't have to buy anything and stick it on the machine. It was already there. You already had data in there, basically. And then you have other companies who are going to approach data collection from the perspective of using hardware or an I/O device. Some do this even if you have a brand new machine. They've just found that it's so much easier to take a well-constructed and thought-out IoT I/O device, put it on the machine, connect it in, and then collect anywhere. Usually it's like 4 signals, 8 or 16. There's different amounts of data input that they're able to collect. There's analog data, there's digital data, there's electrical data. So there's different things that they can do with this hardware. And there's advantages to that. Some people say, I don't need all 250 data points that are native in my particular piece of equipment. They just want to know the basics for collecting OEE. So they want to know there are part counts, is the machine running or not running. There's just very basic things they want to collect. And it might be that even if you have new equipment, that you decide to use a hardware device on the outside of it. And that's perfectly all right. Now, if you have legacy equipment, you're not going to have those kind of options. For you to see your older equipment together with your newer equipment, it's going to have some kind of an I/O or input-output device, some hardware. And then there's another one that I call electrical. This is just using electric currents, and it's not a device that attaches to your machine necessarily. It can just go right on the circuit on your electrical panel, because usually it's one circuit per one machine, and it's an AI device that can actually learn when the machine's running and not running, when it's on, what those cycles are looking like, because it can tell by the pulses of electricity. It's kind of a cool, different approach, but it has its own limitations as well. It doesn't give you nearly as much information as the native connections and the I/O device hardware. So we'll dig a little deeper here. The native connections, there's really three that dominate the marketplace, basically. And these are machines that will have usually printed right on the machine or printed on the controller. They're OPC UA, MT Connect, or Phonic Focus. That's going to cover most equipment, but not all. So OPC was more developed out of Europe as sort of a standard, and OEMs, a lot of OEMs adopted that as a standard, so that if the machine, if your IoT provider connects to OPC UA, then they've already got a way to fairly quickly get information from your equipment if they're working with OPC UA. MT Connect is maybe about 15 years old at this point, and it was another attempt to sort of, let's create one protocol so that all the different machines kind of talk the same language and collect data the same way. I don't think it won over OPC, but certain brands all have MT Connect on them, and MT Connect in some of these IoT platforms really use the MT Connect signals primarily. So then you have Phonic Focus machines. Phonic also has Phonic Focus, where it has tried to create a platform to make it easy to get the data from your machines. And then there's lots of different equipment that has their own controllers on them, and they have their own ways to get information or data from them. The problem with this huge variety of native connections is that they're, talking different languages, and quite frankly, most of your floors, your shop floors, have got a variety of equipment with a variety of different languages on it. And this is actually where the IoT platforms have really learned to thrive, the ones that focus on native. They really thrive because what they do is they have a platform where they can gather in information from all these different places, basically, and put it all into one database in one way that you can see it and visualize that data, no matter how it got to it. And there are a number of companies that are doing this now. We're going to go into that in a few minutes. So I've kind of already mentioned it, but the advantages, you might have as many as 250 data points available, and you're not going to have any additional hardware you have to put on the equipment if it already has one of these connection capabilities. But truly the disadvantages is that it is more complex to connect this whole world. It's been a learning curve for these software vendors that are doing these IoT platforms. They've had to learn to connect to each one of these, and that body of knowledge is growing as time goes on, and as a company has connected more different types of equipment, used different ways to connect, they've gotten better at it. It's getting faster, but it's still more complex than using a hardware board, honestly, or electrical signals. But it has to all go into, put unalike data into one database for this to be useful. All right, so let's look at the I/O device, the hardware. This is an appliance that communicates with a gateway via cellular or Wi-Fi. Sometimes you put a USB stick in to get a Wi-Fi signal. Standard RS-232 or Ethernet cables. There's lots of different ways that these appliances are designed. And I just have a couple examples here for you from Machine Metrics and Mimics and Merlin. The advantage of this hardware is it is usually pretty easy to install. It should be something that you don't have to have a specialist come in and do. There should be good enough instructions that someone with an electrical background should be able to do this. And these devices, like this lab jack, I mean, it's going to get the same data points from different kinds of or unlike machines. And it's going to work for old equipment. It's also going to can go on new equipment. And then you're not kind of overwhelmed with this whole big data concept, right? With too much information. You've narrowed it down. I only need this, and this particular hardware is going to help me get that information from my equipment. Of course, the disadvantage is just that. I'll say something just to think about. Usually as companies kind of go down this whole journey, they find that some data, that the first bit of information, they get the uptime, downtime, and maybe the number of good parts and that kind of thing. It creates a thirst for more information. And just consider, you know, you've in 3 years from now that you've really optimized your OBE as far as you can with the data that you have. Well, the chances are you're going to want more information. You're going to want more sensors. You're going to want more things. The more that you use the information and optimize, and the more information you're going to want. So kind of the disadvantage, I'm going to say, of using a hardware-based approach is that you're going to be limited. Most of that equipment that I've seen out there so far is either 4, 8, or 16 inputs, basically, input, output. So those are how many data points you can get. So perhaps you can never envision ever needing more than that. So if that's the case, then this might be a great approach for you. And there are some fantastic companies that make these devices and make it easy for you to get up and running as far as your IoT platform is concerned. I mean, really at a minimum, what do you need? You need to know if the machine is on or off. You can get this information from electrical information, from switch, and you need to know when parts are completed, when those cycles happen, right? So this might be the approach you want. And then the third approach is one that I'm calling electrical. This was kind of an innovative approach by a fairly new company called Amper. They're out of Chicago, a startup within the last 5 years or so, really up and coming. And I thought it was interesting because they kind of skipped over the machine altogether and said, well, why can't I learn something just from the electricity that's going to each piece of equipment? Most companies, when they have equipment, they have one circuit for each piece of equipment. And then as that equipment draws, each part has its own electrical fingerprint, essentially. As that part is being made, you can not only tell when the machine is on and off, but you can tell variations in how much power it's drawing. And then with some AI and some human input, you're able to start picking up on quite a bit of information just strictly from one electrical signal. So it's just, it is a kind of inexpensive, simple approach, especially for companies who are just kind of getting started and they don't want to go around and touch every machine. So, so the advantages is there's no interruption during the install. Just keep running the machines, go put this over in the electrical box, and bingo, you're up and running and it's working. And in a week or two, you have data to look at. The disadvantages, of course, this is going to give you the least amount of information as compared to the other two methods that I've talked about. You just don't have as much data available to you. It's not going to use any of your PLC information. And so it's perhaps not as expandable for your future IoT platform. And you can see here the different pieces of hardware to this whole thing, which is, by the way, kind of similar to kind of what the home market is even doing now when it comes to sensors. You usually have something that is a gateway where the data is transmitted to the cloud, and you have something where the data is stored, you have a sensor. So this is a very simple approach. So let's talk about some very specific providers of machine data software or IoT platform or machine monitoring, right? I know, so many different ways we can talk about just the terminology here. In fact, I kind of wrote some of those down as we go along, what each company says that they do, because everyone's talking about it in a slightly different language. But I can tell you that these companies basically do the same thing. At the end of the day, they're going to give you automated machine data information, and they're going to have some kind of a software platform where you can see, and Usually it's a red-green format, what's running, what's not running, if it's in cycle, out of cycle. Most of them, I think all of them give you a way also to record your downtime reasons. And so they're all kind of doing the same thing, quite frankly. So we're going to look at Machine Matrix, SensorTrax, FactoryWiz, FreePoint Technologies, Amper, I already mentioned them. They do the electrical circuits, SciTech, Predator, Simco, and Mimics. Maybe one of these will be a good solution for you. So when I either talked with them or went on their website, kind of looked at the question, how do you collect machine data? And, are you cloud, are you on premise? This is kind of what I get. So Machine Metrics really kind of stood out, at least in most ways, quite frankly. And they have kind of an interesting combination here. So they do native connections and they are cloud-based. They provided, they have a huge repository of data because they're cloud-based, and they've been very interesting to follow during this whole COVID mess that we've had, because they've been able to see in real time across huge industry segments now who is running and who is not running, because they can actually tell when machines are not running just in their full aggregation of information. It's kind of fascinating. They do native connections. So they do the NT Connect, the OPC UA, Phonic Focus, and this I list off some of the particular controllers, but they have a lot of different controllers in an IoT gateway. And they started off with the terminology of machine monitoring. They've been around for a long time, and they have really now come along to call themselves, and they are an IoT platform. And they're beginning to develop more apps, for example, and wanting to be able to connect more and more things together. So they're a company you might want to consider. Another one that you'll hear from in this conference is SensorTrax. So they are they're primarily cloud-based. Now, mind you, any one of these companies can tell you they do more than what I'm saying, but this is what I understand. Cloud-based. They have kind of called it manufacturing analytics, which is really great because they're going to provide a solid platform for you to slice and dice your information and really make sense of it. They have a wireless sensor that attaches to all the machines for key data collection. So they're going to be hardware based. They found that that's the fastest, simplest, least expensive way to get your information with these pre-configured sensors for a fast implementation. And they're going to use wireless or cellular services. And then we have Amper. So I mentioned Amper, they do the electrical connections. So native connections, no, they're an on-premise is not actually right. Actually, that's cloud. They collect on-premise, but they push it out to the cloud. And they called theirs OEE and machine monitoring software. But this is an appliance for electrical circuits, and it learns modes, start, stop, run, setup. Very non-invasive. It's using cellular service or Wi-Fi as well. All right, moving along here. Another company you might want to take a look at is called FreePoint. So FreePoint has a pretty powerful cloud connection, and again, receivers with either 4, 8, or 16 input I/O devices that send signals to Wi-Fi to a master receiver. They're a monitoring solution. They're out of Europe. But they seem to be growing and doing quite well. They have a very, very pretty interface, actually, something you might want to consider. And then there's Mimics. Mimics is really strong in on-prem, and they're good for what I'm going to call the larger companies, not so much the small, but more the mid to large size companies, because their OEE software package is going to be license-based. It's on-site, so there's going to be a higher startup cost, and then a lower overall perhaps cost of ownership. But they do native connections and have a huge repository of different types of equipment they've connected to over the years. They have OPC, Phonic Focus, Siemens, and they also have hardware, a 16-point data collecting hardware, I'm calling it, for your legacy equipment as well. They also, a lot of these companies will say they'll do cloud as well. But I know in the case of Mimics, for example, they don't actually do their own hosting on the cloud. They'll work with another company that you would employ that company to buy your cloud space essentially and then connect it in there. And then Simco is a name that's been around for a while. They really were strong in DNC software. And they have native connections are possible. It's primarily on-premise, and they'll sell on-premise is fantastic for security reasons. And as I mentioned earlier, this whole concept between on-premise and cloud is interesting. But they collect the data directly, and they have a number of different softwares, applications essentially, that are all related to the CNC world. And so Simco has nested in their own machine data collection system and with all of their other software packages, and probably is a good selection if you're already using some of their other products. Another fairly big name these days is FactoryWiz. They've come on pretty strong, and they do native connections. They do on-premise. I would say primarily. They may also do cloud, but they do monitoring and DNC using all of the major signals that we've talked about, as well as they advertise very specific machines that they're familiar with connecting to controllers, and they have a hardware option as well. Predator is another one. They have native connections. They're on-premise, and again, it looks quite similar to FactoryWiz. And then we have SciTech. So SciTech has done extremely well in the last year or so. They offer native connections. They do cloud and on-premise types of solutions. They advertise themselves as machine monitoring and OEE software, so there's going to be a large focus on monitoring and seeing your OEE. Now, a lot of these companies can do OEE, but some of them really focus on OEE because they really see your overall equipment effectiveness as being really important to your how you tell whether you're successful and how you tell if you're getting value back from it. So that brings us around to what are the major steps to selecting your IoT machine data solution provider? Well, it's really not that difficult at the end of the day. After you've kind of hashed through with your team creating your requirements, you're going to want to interview or have some conversations with the top 4 to 5 companies in your list, and decide on your top requirements, what your most important ones are, and ask them about those things. And I would definitely cover those key non-technical topics as well to kind of give you that warm and fuzzy feeling of, are they the company you want to work with? Are they going to be a good fit for your company culture? I would invite 2, maybe 3 in for demos. Doing all those virtually these days, but that's fine, whether you do a virtual demo or if you can get somebody on site. That's a great option. Go ahead and take a look, and they'll show you all of the bells and whistles with their system. And then you want to visit some customers if at all possible, one from each of your top 2. Or if you can't get in to visit them, at least have a phone conversation and find out what these other customers have liked about the solution that they've gotten, what benefit have they gotten, what kind of return on investment have they gotten. It'll make a list of a few questions for that kind of an interview as well. And then you'll be ready to make a deal and select someone and get started. You're going to have to sign a contract here. You're going to have to get going with getting connected. But you can do this. And if this project seems overwhelming to you, I'd be glad to help you as well. My name is Rose of Sharon DeVos. I'm with IoT Automated Solutions. I am a company of just one right at the moment. And I do consulting virtually and on site to help companies like you create those IoT requirements and walk you through this process so that you can select your best partner, so that I can ask the right questions on your behalf, perhaps during a demo, whether it be a virtual demo or on site. I'm there to advocate for the small to mid-sized manufacturer. And I thank you for participating today. I look forward to hearing your questions in the chat. And let's see what we can do to make this whole process easier for you. Thank you.